Okay, so there's Sir Francis, all of his glory right there. There's also another, you can't see his face right there, but or you can't see it that well, but that's another picture of him behind me. And so we saw, right, that Bacon makes a distinction, right, between what he calls rational theology, what is sometimes called natural theology, and natural philosophy. So he says, yes, okay, you can know that there's, some first cause of the universe, but you can't really know anything about God's nature. That's not really a scientific claim. That's really sort of a religious claim. And right there, you see a kind of distinction that's familiar to people in the modern period and beyond, that there are religious concerns and they're kind of really totally separate or logically distinct from scientific or empirical concerns. Now, on the natural side, we have natural science, right, which divides into different types of causes, right? So we have physics, which studies efficient causes, right? Like, so for example, one atom barrels against another atom. And if you ask, why did atom B move? Well, because atom A hit it, right? So there's a kind of cause and effect relationship. But then we also have material causes. You might ask, like, what is the atomic structure of something such that, what kind of matter is it made out of, right? For example, if it's a tree, we might say it's made out of like things like bark and wood or pulp or something like that. It's some kind of plant or plant fiber. If we're talking about a stone or a piece of metal, the answer to material causation would be something quite different. Okay, that's okay, Sarah, don't worry. Then we have metaphysics, right? So we have the formal cause, right? And we have the final cause. The formal cause gives us what Bacon calls forms, which is the kind of arrangement of the matter of something. So imagine that you had more or less the same kind of atoms, if you will, in, say, a maple tree and, say, maybe a daisy or something like that. I don't know if that's even remotely true, but let's just say that the matter is kind of similar, right? The difference between the maple tree and the daisy flower is really going to be in terms of the form. They have different forms. If you look at them under a microscope, they'll have a different kind of arrangement of parts. But then Bacon says final causes, right? Purpose, right, are things which we can't really know about. Right? And this is something that Descartes also talks about. And then lastly, we had this thing called what he calls natural magic, which is sort of a very odd way of sort of describing how we would go about using knowledge to produce effects, which we do in simple ways, like when we light a campfire, for example, because we know things like heat or friction produce, fire, or combustion, or call it what you will. And we do it with other kinds of things, like when we take aspirin to alleviate pain and so on. And then, of course, we saw that we're increasingly dealing with a world in which the universe is set up so that the Earth is no longer the center. The center is the sun. And so Bacon really is making a distinction, right? He's saying we can know that a primary cause exists. But really, the interesting thing for the scientist, or really the only legitimate thing for the scientist to know, are secondary causes. So those are all the things kind of operating in the world, right? Those are things like electrons, protons, neutrons, people, bunny rabbits, species, those kinds of things. So we saw with enumerative induction, right, we have a kind of sample which we just sort of construct on the fly, so to speak. So I use the example of swans. There's a swan there's a swan there, everywhere a swan, so to speak. And we notice that all the swans are more or less white, right? And so we conclude, I guess all swans are white. Although that fudges it a little bit, we should probably say all the swans I've noticed so far are white. But if you see enough swans at some point, and I don't know what enough would be, at some point you say, okay, damn it, they're all white. Or you think of the example of, say a medical issue like a headache, and maybe you notice that after you fill in the blank, you eat a slice of bread of a particular type, you, I don't know, do exercises, you stretch, you eat a particular type of food, you take aspirin, whatever it is. You notice after doing that your headache goes away, right? Or it's at least minimized. And so then you infer, I guess eating bread gets rid of headaches. But then Bacon says, like, number one, this commits a fallacy called hasty generalization. So how do we really know that this isn't just coincidence, right? For example, how do you know that even if you hadn't eaten the bread that number of times, that maybe your headache would have gone away on its own? You don't necessarily know that, right? Now, what may appear true to you and me, even after examining a problem numerous times, doesn't necessarily have to be true. And this is exactly how we develop things like stereotypes about people, right? I mean, we never really meet, groups of people. We meet kind of individuals, and on the basis of just seeing one or two individuals from a particular group that perhaps we don't like, we infer that everybody in a particular group is that same way, right? And I gave, a medical example, right? The case of Vioxx, which was a painkiller that, actually killed people or, caused heart damage and so on. And that's kind of an interesting case because the Food and Drug Administration had, and we know this, they had allowed it to be rushed to market. That people really wanted to be able to sell this because there was a lot of money tied up in it. And of course, did this mean that Vioxx was a safe drug? They thought they had enough data to support that claim, right? But that claim was really not well supported. So this again is a kind of hasty generalization because the more data you have, you wind up saying, Vioxx never should have been put on the market to begin with. And then a second thing, Bacon points out is that we don't really, with enumerative induction, we don't really know why bread does what it does. We don't really know why Vioxx does what it does. All we really know is that there's a kind of succession of events, right? Hey, I ate the bread and the headache disappeared. But that doesn't explain how the bread got rid of the headache. It doesn't prove that it got rid of the headache. But even if it did get rid of the headache, it doesn't explain how it happened, why it happened. So we need a more robust form of induction, according to Bacon. And so this is where he introduces what he calls eliminative induction, right? So when I say eliminative induction, which is a bit of a tongue twister, you might think, okay, well, this is Bacon's preferred method of induction, right? And so he says science is supposed to discover these forms, as we said before. And we also said forms are, I think, analogous to something like what we call like a material arrangement of parts, kind of like what you might study in physical science or chemistry, where, the teacher comes out and he or she says, okay, beneath the naked eye, right? There's a structure to things, right? And that structure is another way of describing the thing's kind of internal nature or constitution, right? So you ask when you're a child, perhaps, why is it the case that a leaf is a particular color, is a particular size, is a particular shape? And this has everything to do with sort of the underlying kind of atomic makeup of the tree that produces or grows that particular leaf or branch or whatever it is you're investigating. So that's kind of what he means by a form. And then we looked, and there are so few details Bacon gives us, right? He talks about heat, but that's kind of it. So we're a bit stuck, as I said. So he talks about the form of heat. And he says, if you discover a form, you can only do this if you don't make assumptions and you make observations, right? So we have to use some kind of method, and this is really the thing that makes elimination different than enumeration. With enumeration, all I'm really doing is I'm kind of walking around almost like with a notepad, right? And I'm writing down, okay, there's a swan, and there's a swan, and there's a swan. But with eliminative induction, it's more, you might say, sophisticated in a way, because what we're going to do is we're going to sort of compare and contrast different observations we make in a controlled way. And this will lead to the possibility that we can falsify certain beliefs that we have about whatever it is we're investigating. So if you remember, Bacon says that there are kind of, I think he calls them tables. I called them like columns. So I drew a little thing like on a scratch pad. You know, you could have a column A, where we report, okay, these are all the cases where we definitely find things with heat. So you think, you know, sunlight, maybe, you know, fire, maybe a nuclear explosion, you know, at Chernobyl or something like that, right? And then you have another column where, look, there's definitely not really any heat here. Or, you know, maybe there's some, but it's barely detectable, right? Like you've got, you know, a frozen tundra. You've got more or less the entire state of Texas right now, as I imagine from the news reports, and so on. And then finally, you have a column where you have various degrees of heat. So they're more or less kind of warm or cold-ish. And so that meant, of course, that we make sort of observations, right? We start thinking, what do we have in this presence column, right? This column A or table A. And you think of things like direct sunlight, fire, nuclear reaction, what have you. And then you think of, well, absence, right? Well, you think, well, dead things tend to lose heat. Let's see, liquid nitrogen, ice, snow, dark places like caves tend to be colder than lit places, and so on. And then finally, you think, well, what's left over? We have, well, maybe we have a day where it's pretty warm, but it's not very warm because we have like lots of cloud cover, or maybe we're in the shade a little bit. And so you think, okay, so there are, just as there are things that don't have heat and other things that have a lot of heat, there are things that have more or less heat or more or less cold, and so on. And so Bacon, of course, gives us a method that kind of follows more or less what I'm describing here. And so then he says, okay, so what can we really say about heat? And, you know, you could say actually a fair amount, right? You find it not just in solids or liquids, but also in gases, right? For example, if you boil water, the water will be hot. I suppose if you boil anything, it will be hot, but the heat, the boiling point will be different for different things. Hot things vary according to their color and consistency. So you can't tell that something's hot just because it's red, for example, or orange or whatever, although it oftentimes is that, but not necessarily. Hot things are often in motion, whereas cold things often are stagnant or static. Living beings tend to be warmer than non-living beings. So rocks tend to trap less heat than, say, an animal that's alive. And of course, we know that some things are less or more warm than other things. And we know probably the hottest thing that we can think of, aside from maybe a nuclear explosion, would be something like fire or sunlight, right? So anyway, that is Bacon's method. And as I said in the last class, on the one hand, Bacon gives us or attempts to give us a method. So he recognized, you know, if you're going to do science, you need some kind of methodology, because otherwise you can't control for the possibility of error. And that's great. On the other hand, though, there are certain problems with Bacon's methodology. Not the least of which, as I mentioned before Bacon died from trying to conduct an experiment in winter with a chicken, if you recall. Bacon himself never really produced any substantial scientific knowledge, scientific discovery. So you might think if his method was really the right one, and if Bacon was a really good practitioner of that method, that Bacon would turn around and have given us not just the method, but he would have said, oh, okay, the atomic weight of oxygen is 16, and so on, right? But he didn't do that. So what's going on here? What makes Bacon's theory somewhat problematic? So there are a couple things. So the first thing is, as I think I mentioned in the last class, Bacon assumes we can make more or less exhaustive assumptions or observations about the world. So given enough time, we can make enough observations to discover scientific truths. But how many observations do we have to make? And you might think it's going to be extremely difficult to make enough observations to discover some knowledge, right? So Bacon owes us some kind of answer there, right? How many observations do we really need? And he seems to think about it like in terms of, well, we have to exhaust all of these possibilities, but you're probably going to die before you're able to do that, right? So I don't know if science is possible given that model. Second thing I mentioned in the last class, observation relies upon assumptions, right? So I mentioned this case of what's called Occam's razor. All things being equal, we think the simplest explanation is usually the most accurate. So we have 10 students, they go out to, I don't know, a sushi bar or whatever, and all 10 students after eating come down with some violent illness. And so we assume that it's probably more likely that all 10 of them got food poisoning from a particular item, maybe, that they all ate. Then a rival hypothesis, which would be maybe all 10 of them would have got sick anyway, right? Maybe one had, the flu, another had COVID, another was going through chemotherapy with, another was going through drug detox. There could be 10 different explanations, but generally speaking, we sort of advert to the simplest explanation. Or, that kind of example I mentioned from chemistry class, right? In, say, high school, right? You do an experiment in a chemistry class and you don't come up with the right result. The teacher doesn't probably look at you and say, man, you cracked it, right? It's like the entire periodic table is wrong, thanks to you, right? No, they just say, no, you must have done the experiment wrong. So if water does not boil at 100 degrees Celsius, right, we don't think that the boiling point is actually wrong. We think that there's an alternative explanation. The explanation might be maybe what you're boiling is not water. Maybe the pan is not conducting heat. Maybe somebody turned the power off to the Bunsen burner, right? Maybe like the gas line, nobody at COC paid the gas bill. So, we can't actually use a burner to heat the water and so on, right? Or maybe we're in outer space, or there are different atmospheric conditions that change the circumstances, so the boiling point is somewhat different. But we usually don't say, you falsified all of this other data. So the last thing I mentioned in the last class was, which sort of connects with this idea in point number 2 on the previous slide. If you really want to hold on to a theory, you can. It's called saving a theory. But you can do this through what are called auxiliary hypotheses or ad hoc hypotheses. You just sort of say, okay, there's maybe a way that I can explain rival evidence to save my theory. So if I really want to believe that all swans are white, and I come across a non-white swan, say like a black swan, I can dismiss that occurrence as being an optical illusion. Or I can, it looked black, but now my eyesight's going, so it probably wasn't black. I'm sure that all swans are white. Or maybe all swans are white, but somebody painted the swan, right? Or, you know, maybe the devil put the swan there in order to throw us on a false scent, in order to get us to believe, right, that it's false that all swans are white, right? Maybe it's not a swan, it's a cousin of a swan, right? So it's, you know, it's kind of like, you know, like cousin, like chimps and gorillas and human beings are kind of like cousins in a way, right? So you could say maybe like this thing that we're calling a swan, right, is similar to a swan, but it's not really an authentic swan. So that can be black, but all swans can still be white. Now, if you want to explore this kind of idea, and many others for that matter, in a little more depth, you might check out this guy who's not a modern philosopher, he'd be a contemporary philosopher, although he died about 20 years ago, and this would be Willard Van Orman Quine, who spent virtually his entire academic career at Harvard, aside from time that he spent at foreign universities. So Quine came up with something called the web of belief, right? So Quine said, all of our beliefs fit into a kind of interrelated context, a bit like sort of a spider's web. So Quine says there's not one belief that we have about the world that we absolutely have to hang on to. You could sort of get rid of, you could falsify, you could jettison any particular belief or set of beliefs. But you can only do that at a cost, because those beliefs are going to be connected to other kinds of beliefs. So, for example, if I believe that all swans are white, right, and I see that something in my world looks like a swan and it happens to be black or pink or some other kind of color, right? I don't have to falsify that belief. I can just adjust other beliefs, right? I could say, okay, I can't both say, for example, that all swans are white and I just saw what looks like a black swan and still believe that my sense perception is 100% accurate. Those beliefs can't go together. I can't both say something is a swan and say that's a swan and that's black, right? If I'm committed to the belief that all swans are white. Some belief has to go. Like another kind of silly example, or maybe it's not so silly, would be think about the moon landing, right? Lots of people believe that, although I think you could say this is a minority view, that we never landed on the moon. This was actually an elaborate hoax. Now, you could give up your belief that man landed on the moon, but you can only do that if you give up other kinds of beliefs, right? Including a belief that says everything you see on television has to be real, or the government would never lie to us, or people like Buzz Aldrin and Armstrong and Collins and all these other people that you can't both say that they're heroes and they're trustworthy and they're honest and say that they're a bunch of liars at the same time. So think of another example, right? If we have 5 people and they all die while taking a medication in a drug trial, do you have to believe then that the drug is dangerous? No, you can avoid falsifying the belief that the drug is safe by adjusting your other beliefs. You could say, well, for all we know, those people were going to die anyway, right? Maybe they had undiagnosed heart conditions or whatever. So these beliefs are all part of a broader kind of web or context, right? And this is something that Bacon doesn't really address, right? Because all of our beliefs don't exactly map onto the world in a very clear way, because every belief we have is connected to other beliefs in this web, right? Now, here's the last point, right? Which is very important for what we're going to see in a few minutes. So Bacon assumes that we can discover the laws of nature. Now, Descartes is going to say we can do science of a sort and we can discover the laws of nature. But Descartes' first going to seriously entertain a lot of doubt about our beliefs about the world, including this doubt that maybe our senses can't be trusted, right? So Descartes' going to question whether we have knowledge at all. Whereas Bacon kind of starts out with this idea, like once he talks about the idols, it's almost as if, like, okay, so I just make these observations, and if I'm careful, then the observations will somehow show me the truth. But Descartes' going to say, look, it's a lot more complicated than that. We have to be able to find a way to show that our method, it leads to truth, and that whatever kind of faculty we use to discover the truth, whether it's our sense perception, it's our reason, it's some kind of intuition or whatever, that this is certain. Because if it's not certain, then we're dealing with degrees of doubt. Okay, so now we're going to conduct a little experiment, right? So I would direct your attention to the exercise on the screen. So this is what we're going to call the reality checklist. And no, this is not really a scientific test or whatever, and you'll see why in a minute. So we have three columns, as it were. The first column on the direct left just says object. And beneath that term object, you have a variety of some relatively ordinary, at least familiar kinds of objects in the world that you probably thought about from time to time. For example, we have Antarctica, we have the American Civil War, we have electrons, we have the desk in front of you. If you don't have a desk in front of you, think of another kind of solid object in front of you, like your computer, maybe, a brush or a comb or a chair or something. We have September 8th, 2020, the number 3, leprechauns, right? And, I could have given you more on this list, but this is enough. And then we have two other columns, right? So the middle column is a fill in the blank, right? For each of these objects, explain how you know that this object is real, right? So for example, is it sense perception? Do you know it's real because God or an angel happened to tap you on the back and say, by the way, it's real? Is it real because of something you read in the book? Is it real because of some extrasensory perception or what have you? And then the last column is how certain are you about that evidence, right? On a scale of 1 to 10. Let's say 1 is the least certain that you could have, certainty you could have. So for example, take leprechauns, because everybody picks on leprechauns, right? Let's say you believe that leprechauns are definitely non-existent. You don't think they exist at all. I mean, except like as an idea, because we're obviously talking about them, but you don't literally think that there are little people in Ireland that go around doing mischievous deeds. Okay, fine. I get that. Great. If you really believe that, you got to put down a 1 next to the leprechaun in that third column. By contrast, if you really believe your evidence for leprechauns being real is absolutely rock solid certain, then you're going to have to put down a 10. Everybody understand what I'm talking about? So the reason this is not scientific is A, everybody here is going to be giving different responses probably. So there's going to be no uniformity to these answers or these numbers. And B, it's very difficult, ordinarily speaking, to, I think, judge how certain your evidence really is, which is another kind of problem that's baked into this. All right, let's take about 3 minutes and just in your notes, just jot down like, okay, electron, okay, I know it here, okay, and the evidence is 2, 3, 4, 7, 8, 9, 10, whatever, okay? All right, so let's just take a couple minutes and just do that. People I can't see, but maybe to just give like a little thumbs up. Okay, thank you, Angela. Okay, that's good. So it looks like most people have indicated that they think that Antarctica somehow exists. So then the follow-up question would be, if somebody were to ask you, well, how do you know then that Antarctica exists? What would your answer be? I mean, how would you go about proving to him or her that Antarctica is not some fictitious thing, but it actually really exists, right? That the landmass is real? How would you do that? Yeah, so there are supposed to be
Travel there yourself.
various think tanks, scientific and military. It's supposed to officially be non-military, right? But I think everybody violates that to some extent, right? Including the Americans, right? So yes, it may be possible on some kind of high-powered radio or maybe even through the internet or whatever to contact a person who is Antarctica. Of course, if you do that, then the obvious question would be like, well, are you in Antarctica? And say they're on a video screen and they show you an image outside of like snow or whatever. I mean, that could be like northern Norway for all you know. It doesn't necessarily have to be Antarctica, right? So it's not going to seal the deal, but certainly if you were ever never able to raise somebody on a radio in Antarctica, you might think, okay, they're either all dead or maybe the whole thing's an elaborate fiction, right? What else? What can we say? So Justin says, hey, it's like do what E.T. did in the movie E.T. Phone home. Except you're not phoning home, you're phoning the Antarctic, and you want to talk to, I don't know, somebody like that, right? Although I always have this image, because I love the John Carpenter's movie, The Thing from 1982. I always have this image that if I were in the Antarctica, Kurt Russell or somebody else would be there, and like we would all be killed by an alien. So that's my image of Antarctica. Yep. So what else? What can we do? What about photographic evidence? We've probably all seen photos of people who have claimed to go to the Antarctic, right? Like I had some neighbors before that said that they went to the Antarctic on a cruise and they showed me pictures of, glaciers and so on. And I was like, wow, that looks really pretty, right? But how do I know that that's not like Norway or something like that, right? But I believe them. So I guess we could say we believe certain people more than others, right? If we read something in a book, if we get something from, what we regard as a reputable television or newspaper or other media source, right? Back during the moon landing, right? One of the famous people in the American press corps, Walter Cronkite, came on the air. He was the same guy that wept when Kennedy was assassinated, right? So then he comes on in 1969. He's like, yes, we're on the moon. And because everybody believed Walter Cronkite was this really ace guy that they could trust, nobody would think of doubting Walter Cronkite, right? Whereas nowadays, I think everybody seems to doubt everybody in the media. So I don't know if that would necessarily be the best, source of information. I mean, maybe Walter Cronkite was wrong, right? Maybe he couldn't have been smoking crack because it wasn't invented in 1969. But maybe he was hallucinating, right? Maybe he dropped acid, without even knowing it necessarily. I'm Walter Cronkite, and hey, I think we're on the moon, right? That could be.
And the moon landing was a huge, huge reason why so many people went out and bought televisions. They were looking so forward to it that there was this boom in sales. So,
right. And everybody wanted color TVs.
Yeah, it served many purposes.
Right. Yes, exactly. So you have this kind of economic question here of like, well, wouldn't the media want you to think, right? Mm-hmm. Things like the moon landing were real because it gives you an incentive for tuning in, and the more you watch, the more they can sell products on the air. That's where they get their ad revenue from commercials and so on. Yeah, so the more you think about it, I mean, you could poke holes in this. You could say, I think Antarctica is real. Now, I don't think anybody has said the most obvious thing, which would be, maybe you went to Antarctica. Is there anybody who's been to Antarctica? No, so nobody in this group has actually been to Antarctica. Neither have I, right? But notice, even if, say, Justin had been to the Antarctic, I mean, we would have to trust Justin, right? I mean, maybe Justin went to the Antarctic, but, maybe he's lying, or maybe he's incorrect, right? Okay, but maybe the Antarctic maybe that's a bad example, right? Because you think, well, if you think of Quine's web of belief, you could stop believing in the Antarctic, and probably most of your other beliefs probably will still kind of gel together. They'll sort of cohere. I mean, think about it. Do you need to really think about the Antarctic in order to pay your taxes or drive your car or watch television? Or no, probably not. You really don't. What about the American Civil War? So it was Guyana. Guyana, is that eventually, right? So Guyana said something quite interesting. She said, so when you ask, does X exist? Are we talking about something that existed previously or will exist? Or are we talking about something that has to exist now? So the American Civil War kind of speaks to this, because if you think the American Civil War exists, then you probably wouldn't say it exists in the present tense. You'd probably say it existed in the past, right? So how about that, right? Would you say that the American Civil War exists? You probably wouldn't say it literally exists now, but you might say it's not a fiction. It did exist in the past. So what's your evidence for that? So you can go to Gettysburg. You can read letters written by soldiers and other people from that time. You can read about certain bits of history about people like, Lincoln. So, you could argue that without the Civil War, right, maybe Lincoln would not have been assassinated, right? So history might have been very different, right? So that's true. So would that absolutely, like if you go to Gettysburg and you have, like a tour guide, a docent who sort of says, okay, this is where Gettysburg took place and everything. Would that sort of seal the deal? Would that prove that Gettysburg actually did occur? And Gettysburg, of course, was one of many battles in the American Civil War. Or could you still poke holes in that? Could you still say, well, I mean, that evidence gives me some degree of probability that it existed, but it doesn't absolutely prove it had to have existed? Is it possible to doubt that? Like they wanted to sell tickets to get into like reenactments or something like that, right? Which would be that'd be a very strange sort of, justification for doubt. But sure, I mean, it could be, right? I mean, if you think about it, something like these kinds of historical events that take place over a long period of time, right? Especially a war, like the American Civil War, in a way, can't exist in the same way that Antarctica exists, because not only does Antarctica presumably exist in the present and the American Civil War doesn't, but Antarctica is sort of like one thing that exists all at once. It's a landmass. Whereas the American Civil War is a series of different things that we group together and we put a label on, right? Kind of like World War II or like the 1970s or the 1960s or something like that. It's more of a collective now. So in another way, you could say, you might doubt it from the point of view of, well, do groups of things actually sort of exist, or do only individual things exist? So you have individual battles, maybe, you have individual people and bullets and so on, but we're grouping them all together and we're saying it's like one thing. But in a way, that's not really quite true. It's like saying that Congress is one thing, right? But there's no living member of Congress from 100 years ago, right? So the membership of Congress changes pretty constantly, although given the fact we don't have term limits, it doesn't change all that often, but it does change, right? So you could say even a collective term like the United States or the United Kingdom or France or whatever, these things refer to things that constantly change over a period of time, whereas Antarctica, yeah, it changes, but it doesn't seem to change that much. But what about electrons? Probably everybody said electrons are like a 10, right? Would that be fair? Does everybody believe in electrons?
A 9.
So, Guyana, can you see stars in the sky?
Oh yeah, I can see the light.
Could have pulled the plug a long time ago, and even though light travels at 176,000 miles per second, right, or thereabouts, it's fast, right? It's still possible, given the amount of light years it would take for light to catch up to us, to our point of reference. It's possible that any star you see in the sky tonight may have ceased to exist, 1,000 years ago, for example, right? And all you're really seeing, I mean, like, you could look at the moon, for example, and you could say you could cover up, one of your eyes like this and not even see the moon. It's not like the moon is as big as your thumb, right? So the thing that you're actually seeing is not the moon, or it's not a star, or not, light from millions of miles away, for example, but rather you're just seeing sort of an image that's in your retina, right? That basically is connected somehow to your optic nerve and interpreted in a certain way. So Guyana says you can't see electrons, so I have to trust that they're there. Of course, we could ask, well, why trust that? I mean, it seems possible that, if we're doing epistemology, if we're thinking about knowledge, it's entirely possible that maybe you could be wrong. But somebody else, I don't know who said it, they said it was a 9. I think it was Justin or somebody else. Maybe
a 9. Kind of going on the thing of trust. I've heard it since I've been in school. It seems like if you watch any science documentaries, you're going to run into those kind of things, right? So I trust that it's there, but also, like she said, I can't see it. I don't study it myself, but I trust that it's there, So I gave it a 9.
Okay, so that's a good point. So imagine that you went into a science class in grade school, say it was like 3rd grade, and somebody gave you some theory about the world, right? So here's sort of one example. Before oxygen was discovered, people believed that there was a kind of, I don't know, I think they defined it as either a gas or as some kind of like ether that existed in the atmosphere called phlogiston. And they thought phlogiston was a substance that existed inside solid objects. So, for example, you could have phlogiston in, say, like a hunk of like iron, right? And when the iron, becomes decayed, like if you heat it up or whatever, when it changes color or whatever, that would be because you're releasing this thing called phlogiston from the inner workings, the inner kind of form of the iron or whatever the object is. And the phlogiston is the thing that explains why things sort of change color or they change shape or whatever, right? And up until about 200 years ago, 150 years ago, right, people believed that phlogiston probably existed. Now, of course, nobody talks about phlogiston. In fact, most of you probably have never even heard it, except maybe as a historical curiosity, right? Like you might have been lucky, you had a science teacher who said, hey, back in the day, people believed in this thing. But for the most part, unless you're studying the history of science, you'll never hear about phlogiston. So imagine that you went into a class and somebody said, hey, kids, there's something called phlogiston, and it's a substance that exists inside of other substances. And when it's released, it produces, fire or smoke or discoloration or any number of different kinds of things, right? And you're like, oh, wow, that's interesting. But then you went off and nobody else believed in this theory, right? You went up to like other scientists or science teachers and you said, hey, what about that phlogiston? And they kind of looked at you like, I've never heard of that. Or who told you that was real? I mean, we debunked that, 2 centuries ago. If nobody believed in it in any kind of consistent way, if it wasn't in any textbook, in fact, if you found things in textbooks that said explicitly phlogiston has been falsified, it doesn't exist, you'd be hard pressed to actually believe in it. But then Alex comes along and Alex brings up a really good point. He's like, well, look, I don't study electrons in any kind of systematic way, but it seems to me that electrons probably exist because like all these people talk about them, right? It's like in every science book, every scientist talks about it, even people that just have like a basic kind of science background, right? Like, say somebody like Bill Nye, for example, the science guy, right? I mean, like, is he a world, is he an award-winning, physicist or chemist? No, he has like, a master's degree in science of some sort, right? So you think, okay, like everybody from Bill Nye to like your high school physics professor knows something about electrons, right? So it's a common kind of belief. But notice, just because a lot of people believe it doesn't necessarily mean it has to be true. And then Guyane comes along and she says, well, wait a second, I can't see it. And that's true. I mean, even the scientists that say that electrons, protons, neutrons, and so on exist will have to admit that you can't see it with your naked eye. You might see a blip of what they call an electron on a screen. You might be able to predict certain effects that happen because you think electrons exist, but we don't literally actually see them. And so you could say maybe electrons don't exist, but then we've got a problem. Do we want to say that anything we can't perceive directly with our senses doesn't exist, right? That may go too far because presumably there are lots of things, right, that we can't sense that probably exist. I mean, I can't sense my cat right now because he's in another room, but I assume he still continues to exist even when I'm not perceiving him, right? But how do we know, right? I mean, we never perceive an unperceived object. So for all we know, whenever you're not perceiving anything, the object's not there. And in fact, given one theory about quantum mechanics, that's exactly what happens, right? Your room doesn't exist until you open up the door, and it goes from an indeterminate state, and all of a sudden you observe it, and whoosh, the room comes into being, which is pretty cool. Okay, so I'm guessing that between the electron and the desk in front of you, probably most of you had numbers that were, except for maybe not Guyane, right? At least for the electron, right? I'm guessing most of you had numbers that were at least a 5, probably a 6, 7, 8, something like that. Because you might think, well, look, I can't doubt an object that's right in front of me, right? I mean, it's here, right? But again, that assumes that you can trust your senses, right? So here's a little experiment, okay? Let's imagine that we think about knowledge. So I use this term knowledge or to know or words to that effect pretty consistently over the past few minutes. And of course, that's no accident, because when you look at Descartes and Bacon, and indeed a lot of modern philosophers, they're focused on epistemology. They want to know, what can we know exists? How can we know it? What do we mean by knowledge anyway? How does knowledge and doubt and certainty and all these other terms, how do they kind of all relate to each other? So I'm going to try to build a sort of explanation that will give you an idea of a theory of knowledge here. So you look at the statement and it says 2 + 2 = 5. And probably everybody thinks this is a somewhat curious statement, right? I mean, it is a statement. It makes a claim. Basically says if I have 2 things and I kind of combine them with another 2 things, I'll get 5 things. But you probably think, okay, yeah, but that is suspect, right? Because you think 2 and 2 don't make 5, 2 and 2 make 4. So you got this guy, right? And he's, kind of curious. Like, I mean, is that really, really true, right? And then you have Dr. Evil here, right? And Dr. Evil is like, hey, maybe we could believe this, right? Maybe some of us will believe this, but really most people are not going to believe this. Let's say anybody who has at least a basic understanding of like the number line that a lot of us used in grade school, anybody that's ever counted with their fingers is going to say, okay, if 2 + 2 = 4 rather than 5 on a Monday, it's not going to change on a Tuesday or a Wednesday or whatever, okay? Now, what this means, of course, is that if a person, let's say Dr. Evil, or getting back to this guy, let's say either one of these gentlemen or both of them believe that 2 + 2 = 5. This would hardly be a form of knowledge, right? Because they believe something that's manifestly false, right? So if you happen to believe that leprechauns exist, but it turns out leprechauns don't exist, then you have been fooled. You're not a poster child for being a knowledgeable person, at least as far as leprechauns are concerned. Now, Second thing to consider is take this depiction of the Earth, and I know this is this will probably disturb the flat earthers in the audience because it doesn't quite look absolutely flat, right? And also it doesn't look like a globe, it looks more oval. But be that as it may, who cares, right? So on there we have Hawaii, which of course is west of us in California. And we have Japan, which is also west of us, but considerably further north. And then we kind of have, you know, this Mariana region, and the Mariana Trench is actually, we're told, the deepest part of the Earth's crust. So if you want to go, I think it's something like 56,000 feet or something like that. It's like 7 miles, right? I mean, it's ridiculously difficult to get to, right? Because there's something called crush depth, right? You see all these, you know, if you ever watch the movie Das Boot, which is about, you know, a German U-boat, right? They get down too deep in the ocean and like, you know, the boat is going to collapse into itself, right? At some point, even structures made up of metal, right, just kind of implode. So it's really, really far down there, right? Now, yes, it's actually, it's 43 miles average width, right? And it's actually 6.83 miles. So it's not 54,000 feet, it's 36,201 feet. So I guess that's the deepest portion. Okay. Now there are other trenches or gullies, if you will, or holes on the surface of the planet, but this is the deepest one that we know of, right? So most of you, now some of you obviously have heard of the Mariana Trench. I'm sure you have. Anybody that's ever studied oceanography has probably heard of it, you know, but probably a lot of you, I'm guessing the majority of you have probably never heard of the Mariana Trench until today, which is what I'm here for, to give you seemingly useless information, right? I'd be very remiss as a philosopher if I didn't do that, right? But think about this, right? The Mariana Trench. A minute ago, if you didn't know what the Mariana Trench was, if you'd never heard of it until I told you, you couldn't possibly have any knowledge about it, right? You can only have knowledge about stuff, right, that you have beliefs about, and you can only have beliefs about stuff that you have some awareness of. And a minute ago, you had no awareness of it. So knowledge not only has to be true, it has to be premised on some belief that you actually have. And because some of you did not have a belief at all in the Mariana Trench a minute ago, you could not have had knowledge. So you got this little kid. He's like, the Mariana Trench, who knows? Who knew? I didn't know. There you go. But now he has knowledge, or at least potentially he has knowledge because we told him about it. So knowledge implies that we have some kind of awareness of something. So that's another part of this kind of definition that I'm building towards. Now, let's think about this claim, right? Montreal is north of New York, right? So you look at this map right there and you see New York State and New York City, and you have Montreal. Now, it's true, we could haggle a little bit. It's not absolutely dead center north, right? You could say it's probably something like, you know, north with just like a couple degrees of like northeast or something like that. But it's basically, if you travel north, you know, by some road, that's the right direction. Let's just put it that way, okay? So it gives you some kind of idea of where Montreal is. Now, how do I know that? Well, I gave you a map, didn't I? Right? There's the map. You've got Miami, Orlando, New York, Bar Harbor, right, which is in Maine. And you've got, you know, parts of Nova Scotia and Newfoundland and so on, right? And of course, you have Quebec, which includes Quebec City and Montreal and just Canada broadly, right? So you got this little kitty cat right there. He's like, okay, I've got this, right? I've heard about Montreal, I've heard about New York. Yes, definitely this is true because I have evidence for my belief, right? Now, let me just skip over this next bit just for a minute because I want to show you something and then I'll sort of come back to this in a minute. Okay, so we have Descartes here. Those are Descartes' dates, okay? By the way, Descartes, again, a bit of a death by misadventure. He died in Sweden. He was a tutor to Princess Christina of Sweden, and she was enamored with philosophy, but unfortunately, she liked to get up very early in the morning and walk outside and learn about philosophy. Descartes didn't like to get up before noon, and he did a lot of work in bed, apparently. And apparently, this is how the story goes. He caught a nasty cold tutoring her in philosophy and then died. So there you have it. So you have Bacon with the chicken and then Descartes with the princess. So we have this question, what is knowledge? So here's a theory of knowledge, right? For any S, so, and by an S, I mean a subject that can have knowledge, that can entertain knowledge claims. So what does that include? Minimally, it includes us. And by us, I mean all human beings who have at least some basic threshold of rational ability, right? So for example, maybe somebody who is comatose may not apply here, right? But potentially human beings, by and large, could be an S. It could also maybe include like an intelligent robot or a computer. That's more of a debatable point, whether or not those things can be conscious or have knowledge. But you sort of get the idea, right? For any S, S knows P, which is some proposition about the world, if and only if the following three things obtain. P has to be true. So remember the first thing I said. If you believe that 2 + 2 = 5, or if you believe that the earth is flat, you do not have knowledge. You have falsity or falsehood. Second point, S has to believe P. So if you've never heard of P before, you're like that little kid who a minute ago didn't know about the Mariana Trench. If you've never heard of the Mariana Trench, then you cannot have knowledge of it. Now, once you hear about it and other conditions are kind of met, then potentially you could have knowledge about it. So here's a third idea. S knows P if and only if S's belief in P is justified. Okay? So what do we mean by justification? Well, justification is another word for evidence or warrant. So on one of those previous slides, I asked, well, how do I know that the statement Montreal is north of New York, more or less, as I said, how do I know that's true? How do I know it to be so? And the answer I gave is, well, I have this map, okay? But you have to be careful there. I gave you a justification, right? There's the map. And you're probably inclined to believe that map because I gave it to you. And you've probably seen similar maps before. So that's kind of like what Alex was saying before when he was talking about electrons, right? All these scientists talk about it, right? If every other map you had seen before did not have New York or Montreal on it, you might think my map was a little suspicious, right? But because every map you've probably seen of the United States and Canada, or, you know, that landmass that we call sort of North America, probably has those two cities on it because they're two major North American cities, you probably are inclined to think my map is more or less accurate. Maybe not 100% accurate, but accurate enough to support that belief. But here's the problem, right? You could have a justification for a belief, and yet we might still worry, do we actually have knowledge? I mean, for example, you open up some editions of Lord of the Rings, and there's a map of Mordor right there at the very beginning, right? You can't say Mordor is real just because Tolkien decided to design a map, right? So you could construct a fake map, just as like you could construct a fake theory about the world having to do with phlogiston or maybe electrons and so on. So the rubber, so to speak, is going to meet the road here when we get to this point number 3. How do we come up with a justification that's certain enough that we can say, yes, we really have knowledge, right? So if you put these 3 points together, you have what's called the theory of justified true belief. And if you remember the term justified true belief, you can remember everything I gave you on this slide. And here's why. If you remember justified true belief, or JTB for short, you know that this is a theory about knowledge that says knowledge is something that a person believes when the following conditions are met. It's justified, that's point number 3. It's true, that's point number 1. And it's a belief that's entertained by S, that's point number 2. So justified true belief is kind of, the word, the term, the title kind of says it all. It sort of does all of the work, so to speak. Okay, now, want to leave you guys with a little experiment here. So let me see if I can get to, okay. So we'll be picking this up on Monday's class, right? So on Monday's class, we're going to look pretty in depth at Descartes' meditation 1 and meditation 2, right? So we have to see, we started to see why there might be reason to doubt various beliefs we have about the world, like Antarctica or electrons or whatever. But we're going to have to see how Descartes kind of systematically calls attention to all of these things that might be doubted. And you're going to get to the end of that first meditation and say, geez, it seems like we can't know anything at all. But of course, as they say in infomercials, but wait, there's more, right? You don't want to stop reading there, because Descartes doesn't end up being a total skeptic. He's going to say he can prove certain things do actually exist. So knowledge is still possible. So here's the little experiment, the little thought experiment I want to leave you with. And this is called the brain in the vat. And you won't find this exact example in Descartes, but it's inspired by Descartes. So the brain in the vat works something like this. Imagine that you've got some person, this could be you or me, and say this person, that like this guy here, he falls asleep at night or he's drugged or whatever. And when he's sound asleep, somebody comes into his room and they saw open his head and they steal his brain. Now, why would they do this? I have no idea. That's above my pay grade. I'm just saying some people or space aliens or whoever, they might try to do this. So they do that, and then what do? They put the brain inside a jar or a vat, if you prefer, hence the brain in the vat, okay? And we'll hook it up to a blood supply so that it doesn't atrophy and die. So we're going to keep oxygenated blood going through the brain, so you don't have to worry. The brain will not die. But the brain is outside of the body. The body is now completely dead. It's just like a husk, because there's not even a brain stem there to regulate respiration and so on, and heartbeat. So the guy's body is gone, but his brain survives. Now, the brain, of course, as we know, is based upon some kind of electrical signaling or stimulation. So let's say that we hook the brain up to a supercomputer and we affix various kinds of electrical leads to different sensitive parts of the brain. If you want, you could imagine that we do this like thousands of different places here to stimulate different kind of neurons and so on. So we have a bunch of guys over here. They might be human beings. They might work for the government. Who knows? They might be space aliens who have very advanced technology. So they're sitting there with a bunch of computers, and let's just say these are evil guys. What Descartes, in Descartes' story, right? He'll talk about the malin génie, the evil genius that manipulates our perceptions theoretically. So they can trick us into believing whatever we want or whatever they want us to believe. So here's the brain. The brain is in a vat. It's hooked up to electrical leads, and it thinks that it's outside walking in the sun. Oh, this is so nice. But is it outside in the sun? No. It can't be walking in the sun. It doesn't have feet. It doesn't have legs, right? It's not exposed to the sun. It's not going to get a sunburn, right? Because it's just a brain in a vat in a lab somewhere. It's not outside, it's inside, and so on. It's not in the world, but it's in a vat. So the brain, in other words, can be convinced of virtually anything. So we all sit here, of course, and we're laughing at this dude, right? We're probably inclined to say, hey, you know, the guy whose brain was stolen, oh, that sucks to be him. But here's the interesting question. Can you prove beyond any shadow of a doubt that you're not actually a brain in a vat right now, right? Because it seems like all of the experiences we're having are the same kinds of experiences you might have in a dream, or the sorts of experiences you might have if somebody hijacked your brain and manipulated your perceptions in particular ways. So here you are, you're thinking you've got a body, you're thinking you're in a world interacting with other people and various kinds of objects, and yet maybe that's not actually the case. But you say to me, but wait a second though, I can take the coffee cup and I can grasp it and I can drink it and so on. It's like, well, you can't do that if you don't have a hand. Well, what do you mean I don't have a hand? I can feel it. Well, what you're feeling though could just be electrical stimulation in your brain. You might not actually have a hand there. So, as I said, we will pick up this kind of story on Monday, okay? And as I said, Descartes does not talk about the brain in the vat, but Descartes does talk about the possibility of, you know, being asleep and not knowing it, right? Being in a dream state. So think of some dreams that you may have had where the dream seemed so vivid, so realistic, that you could swear that you were actually not dreaming. If you've ever had a dream like that before, then you know what kind of doubt Descartes is actually playing with here, right? So what Descartes is doing is he's saying, hey, look, wait a second. If 5 minutes ago I was doing what I now call dreaming, but I was convinced I was awake, how do I know that 5 minutes from now I'm not going to look back on this time when I thought I was awake and say, hey, I thought I was awake, but that's actually a dream, right? So today we've seen sort of this kind of point of transition, right, between some concerns that Bacon has and some broader concerns in epistemology, right? So if we're going to try to do science, if we're going to try to make claims about the world at all, like I have a body or other people exist or God exists or whatever, we're going to have to give a better answer than the one that Bacon gave. So that's what Descartes hopes to provide, right?